Okay, we're talking about our chemical reactions, stoichio, test prep. Now remember, you're allowed to use all of your notes, and that's why we're doing at least one of our reviews as a Google Doc so you can use it again to help you out. And you're allowed to use a calculator, whether it's a physical calculator like I have here, or you're more than welcome to use your phone calculator or the calculator and link it for it. So what's on it? Well, we're going to see that it's not only chemical reaction basics, we'll have to balance, identify the 5 types, and then our 2 conversions we've been working on since last week, a mole to mole, which is going to be 2 steps, and our gram to gram, which is going to be 4 steps. Now, we'll see that this test will have 24 questions. It will be worth 100 in the gradebook, our final one of marking period 3, and you'll have 65 minutes to complete it. So you'll be able to use the 44 minutes in class, and then you can come back later to complete it the next day or the same day. It's up to you. So if we look at our first one, we're going to start with the newest stuff first and put our old stuff of chemical reactions at the end. So it says, which of the following is not a correct mole-to-mole ratio for the following equation above? So are there 2 moles of Al? Yes. Are there 3 moles of O2? Yes, so it can't be that one. Are there 2 moles of Al2O3? Yes. Are there 3 moles of O2? Yes, so it can't be that one. Are there 2 moles of Al2O3? Yes. Are there 2 moles of O2? No. So we'll see answer choice number B is the correct answer, meaning that it's incorrect because one of the mole ratios is not the same as the coefficient we see here. So we would see 3 moles yes and 2 moles there. So we would choose B for this one. Okay, now our next one is a conversion. It says how many moles of carbon monoxide could I make if I had 4.4 moles of diatomic oxygen? So we see that this is a mole to mole, and you're actually going to drag and drop on your doc. So if we're going from moles of diatomic oxygen, that's my A, to carbon monoxide, that's my B. Now, when we're doing this, we want to make sure that we always start with our given first. And our given just means that it's the number. So we're going to have 4.4 mol of O2 here. And then we have to look at the coefficient to go on the bottom. So we're going to see that it's 1 because there's no number. And then we're going to go to our unknown, which is going to be the coefficient for the top there. So we're going to see 2 moles of CO. So we made it to the end of this 2-step mole conversion. So notice mole O2 will cancel out. So we're going to do 4.4 times 2 in our calculator. We're just doubling it. So we're going to see we get 8.8 mole of CO, or carbon monoxide, and it already has the proper number of sig figs for it. Okay, so take a moment. You might want to pause the video and actually try this mole to mole on your own to see how you're doing. Okay, welcome back. So how many moles of diatomic chlorine, that's going to be my known right here as my A, are in 1.25 moles of sodium chloride? So remember, we're going to have our given go first. So that's our 1.25. Oh, pardon me. I read my number with the wrong one. So we're going to see our 1.25 mol of NaCl will go first. So we have our mole of NaCl. That's going to be our reactant in this decomposition as A. So we're going to write our 2 moles of NaCl on the bottom. And then we're going to look for our B. We're looking for how many moles of that diatomic chlorine. We're going to write 1 mole on top for that Cl2. So we made it to the end of this mole to mole. So we'll notice that mole and mole will cancel out, and we'll get 1.25 on the top, and we'll get 2 on the bottom. So if you want, you can do it mentally, but remember, you're allowed to have a calculator, whether it's your phone, a physical calculator, or even the calculator and link it. So for this one, we get 0.625. So that already has 3 sig figs. Awesome. We just need to put our unit of mole of Cl2. And we made it to the end of our mole to mole conversion. Okay, so now we're to the big one. We're looking at a grams to grams. Now it's going to be a drag and drop like your Google Doc right now. I'm just showing you how to go through the process. So fill in the things that you know what to do, aka get your given first over 1, and then we're going to have our 1 mole here. We need our periodic table in the bottom. Box out our mole ratio as the third step, and then we're always going to have 1 mole here and then periodic table again for it. So let's figure out, what are we starting with? If 25 grams of iron is reacted, how many grams of diatomic oxygen will be used? So we have 25 grams of iron. That's going to be my A and my starting point. So I'm going to write 25 G of Fe. Then I need G of Fe to come to the bottom. So I find Fe, I rounded to 2 decimal places, so I'm going to have 55.85 there, and then I have mole of Fe. So now we're at the mole ratio point. We're going to look up and see the coefficient, which is 4. So we're going to write 4 mole of Fe there. And then we're going to transition. So our third step is always a transition between what we do know, Fe, and what we don't know, diatomic oxygen. So we find my diatomic oxygen, and its coefficient is 3. In the mole ratio is the only spot where you'll have numbers for moles that aren't 1. And then we'll have to see and round that to 2 decimal places, which actually makes it 16. So for O2, 16 times 2 gives us 32 grams for this step. And so we made it to the end. So gram of Fe, mole of Fe, mole of Fe, mole of O2, mole of O2. So now we just need our calculator to solve. So we're going to find our top number first, and I'll put it right here, and then we're going to find our bottom number because I'm running out of room. So in your calculator right now, you're going to do 25 times 1 times 3 times 32, and we get 2,400 for our top. Then go to the bottom. We're going to do 55.85 times 4, and we're going to get 223.4. So now we need to divide our top by our bottom. So 2,400 divided by 223.4, and we see we get a long decimal, 10.7430617. So you don't have to type it out. We just need to see that 25 grams has 2 sig figs, so count over 1, 2, and will 7 round 0 up? Yes, it will. So we would see that we would need 11 grams to completely react with our iron. Okay, now that takes you through the stoichiometry of your test review. You can go along to the next video to go through your chemical reactions part. Thanks for watching.